Hello. So today's lesson, this is lesson 3.3, which is about percentiles and something we call a box and whisker plot, which is just another way we have of representing or graphing numerical or quantitative data. So today's objective, I will construct a statistical model to describe variability using a box and whisker plot. I will use percentiles to describe where data is in a distribution. So we're going to start with a set of data. Can't decide where to put me. Below is data from TEA, Texas Education Agency, showing the average 2016 SAT scores for several high schools in Central Texas. The high schools are listed in ascending order of SAT average. Ascending means it starts at the bottom and goes up, so it's ascending. McNeil is number 23 on the list. This is MHS right here. Does that mean it's 23rd best? So remember, if it's an ascending order, it's going from lowest to highest. So actually, that would mean that we are 23rd worst, I guess. But basically, 1, 2, 3, 4, 5, we're 5th best according to this list. McNeil's average score is higher than what percent of the high schools? So if I count how many high schools are below us, so all the way up to number 22, so 22 high schools are below us out of the 27 total. That would be how I find that percentage. So we find how many people are below us or schools are below us, and then we turn that into a percent by dividing by the total. So 22 divided by 27 comes out to about 81.5%. So that means McNeil's average score is in the 81.5th percentile. So the percentile describes what percent of data is below a particular value. So if when you were born, you were told you're in the 90th percentile in terms of height, that would mean that your height is longer or taller than 90% of people your age. So that's what we mean by percentile. So let's figure out what percentile Round Rock High School is in. So Round Rock High School is at number 17. There are 16 values below that. So 16 out of the total number of values, which is 27, gives us 59.3%. So Round Rock High School is in the 59th or 59.3rd percentile. So about 59% of schools did worse than Round Rock High School. The next question says, what is special about the score 1460? So 1460 is right here. It's number 14. And if I look carefully at that number, I can kind of see that there are 13 values below that number, and there are 13 values above that number. So that number is the median. It's the number that's in the middle. We've talked about median already. We count to the middle if they're in order, which these are. So let's move on to talk about something called a quartile. So the median is the number that's in the middle of the data. The quartile, if you think about the word quartile, it's like a quarter. Quarter means 25 cents or 25%. So the quartile is a 25th percentile. So that's what the quartile means. You could also think of it as it's the median of the lower half of the data set, not including the median. So if I look at all the numbers that came before our median, which was 1460, so if I look at all the numbers that came before 1460, which would be all the numbers up until Cedar Ridge High School, which is number 13. So everything up to 1407. If I find the median of that part of the data, that is the first quartile. So the first half of the data is everything before HHS, Hendrickson High School. So everything below those numbers. So if I look at those 13 numbers and count to the middle number would be the 7th data set, which is 1217, which was that bottom school's number 7. I think it's LHS, yeah. So Q1, the first quartile, is point number 7 with a value of 1217. So again, first quartile is like the median of the first half of the data set. So then the third quartile, Q3, would be the 75th percentile, but you can also think of it as the median of the upper half. So everything after the median, if we look at those numbers and find the middle number there, that would be the third quartile. So everything after number 14, which was our median, that 1460 number. So all these other numbers after it, if we find the middle number, which would be this 21st data set or data point, which is that 1563 GIHS. right? So that is how we find quartiles. It's basically finding the middle number of everything that came before the median and everything that came after the median. Those are our quartiles. So box and whisker plot is one way to display those five key values of our data set. The inner part of the box describes the middle 50% of the data from Q1 to Q3. Remember, quartiles represent 25% of the data, so that middle 50% is represented on a box plot with a box. And then the line in the middle, or somewhere in the middle of the box, represents the median, right? So Q1 is the beginning of the box, Q3 is the end of the box, the median is that line that's somewhere inside the box. And then the two segments that stick out from each end represent the top and bottom 25%. The first segment starts at the minimum, and the second segment ends at the maximum. So the minimum, Q1, median, Q3, and maximum, those five numbers that we mark on our box plot are known as the 5-number summary. So anytime you're asked about a 5-number summary, we're talking about those specific 5 numbers: the minimum, the first quartile, the median, the third quartile, and the maximum. Those are our 5 numbers that are important here. Okay. And then from there, we get what we call the inner quartile range. I mentioned that in the last lesson, in lesson 3.2, as another measure of spread. The inner quartile range, otherwise known as the IQR, is basically the width of that central box. And it's found by subtracting Q1 from Q3. So Q3 minus Q1 is basically the range of that box, the inner quartile range. So remember, the regular range is just maximum minus minimum. The inner quartile range is Q3 minus Q1. So it's another measure of spread that tells us more or less how spread out the data is, but it's focusing in on that middle 50%, which is where kind of the majority of the data is lying. So we're going to practice for our SAT scores, talk about the 5-number summary. We've already talked about the quartiles and the median, so we just have to add in the minimum and the maximum. So the minimum is the lowest number, which is 955. Quartile 1, remember, was the middle number, the median of the first half of the data, which we found was 1217, everything that came before our median, and we found the middle number. The median was 1460. Was the middle number of the whole data set. Quartile 3 was 1563. That was the middle number of all the numbers that came after the median. And then the maximum number is over here at 1971. So we're going to create a box and whisker plot for those data sets. The first step would be to draw a number line. Your number line doesn't have to start at 0. It just needs to start to where your lowest number is going to fit on the box plot. And it needs to end so that your highest number fits on the box plot, or on the number line. So I have a number line that just makes sure that I'm drawing everything to scale and that it looks like it's supposed to look. So I just started at 900, it ended at 2000, and went every 1,000 in between and drew a line. That way I have everything evenly spaced. Then I'm basically going to put my box. So Q1 is at 1217. So I had my box start at about 1217, I estimated. And at Q3 is at 1563. So I had my box end at around that spot at 1563. Right. Now I'm going to draw my line for the median, which is at 1460. So I drew that line in the middle of the box, kind of where 1460 is on our number line. Then I'm going to draw my lower tail, is what we call this lower whisker, to where the segment starts at our minimum, which is at 955, so about right there. And then I'm going to draw my upper tail to where it ends at our maximum at 1971. Okay. So that is a box plot. And one thing that we can do in terms of finding if this box plot is symmetric or not is we can kind of look at the box plot, but another thing, and we talked about this in the mean and median video or lesson, but we can talk or look at how the mean compares with the median. So if I told you, if I added up all 27 of these numbers and then divided by 27, the mean score for all the high schools is 1421. My median is 1460. So in order to determine symmetry, remember we look at how does the mean compare to the median. If the mean is noticeably or obviously less than the median, we know the distribution skewed to the left. If the mean is noticeably greater than the median, we can say that the distribution is skewed to the right. And if they're roughly at the same spot, we can say it's fairly symmetric. So this is one where I would say that the mean and median are really not that far apart, especially when we take into consideration the entire range of scores. 1421 and 1460 aren't that far apart. So you could say it's roughly symmetric. Now, again, the mean is technically less than the median. So if you said it's maybe slightly skewed to the left or to the lower numbers, that would be fine too. But technically, I think this one's fairly symmetric because those are pretty close. Okay. So now let's talk about outliers. Sometimes some points are really, really far away from the rest of the group. We call those outliers. Outliers just means that it's a point that's super far away from everything else. It's clearly it's outside the realm of what we thought our points would be at. But how do we know for sure if a point is an outlier? There is a calculation for it. So statisticians came up with kind of a way to calculate whether we wanted to call something an outlier. So the rule is that points farther than 1.5 times the IQR. Remember, IQR was the interquartile range. We calculated that by doing Q3 minus Q1. So points that are farther than 1.5 times the IQR from our central box are considered to be outliers. So in other words, lower outliers can be found if they are less than Q1 minus 1.5 times the IQR. And high outliers can be found if they are greater, if a number is greater than Q3 plus 1.5 times the IQR. So if I wanted to test, that lowest value in my list of SAT scores was 955. So if I wanted to know, is 955 an outlier in that data set? So I'm going to figure out Q1 was 1217, Q3 was 1563. So I can find my IQR, which is 346. So 1217 minus, so 1217 is Q1. So 1217 minus 1.5 times the IQR is 3, which is 346. That's what we get when we subtracted Q3 minus Q1, is 698, which tells us that any values that are lower than 698 would be considered outliers. Well, 955, which is our lowest number, is not below 698. You can kind of think of this 698 as, I call it sometimes the lower fence or the lower boundary. So basically this number is saying this is as low as our data should go. Any values below this are definitely outliers, meaning that they're super far away from the majority of the data. So since our number 955 is not less than 698, it's greater, it is not an outlier. So it would have to be smaller than 698 to be considered a low outlier. So let's look at the other example, is 1971, which is our highest score in the data set, an outlier on the upper end. So again, we found Q1 and Q3. We found the IQR, which is 1563 minus 1217, Q3 minus Q1, which was 346. So to find the higher outliers, we're going to start with Q3, so 1563, the upper end of the box, and add 1.5 times the IQR, which gives us 2081. So our value of 1971, that was the highest score, is not greater than 2081. It's less than that. So 2081 is kind of like our upper boundary or fence. We're saying this is as far as the data should go. Anything above that is an outlier. So 1971, which is our highest score, is not above that. So 1971 is not an outlier, right? It would have to be larger than 2081 to be considered an outlier. So if there was a school whose average SAT score was 2100, then we could say that that one is an outlier because it would be above that threshold, that boundary of 2081. Similarly, on the lower end, if we had a school whose average SAT score was like 800, right, that would be an outlier because it would be below, just kidding, not 800. If it was like 600, sorry. If it was like 600, then it would be considered an outlier because it would be below that lower fence, that's 698, right? So once we've determined if there's outliers, we can make our box and whisker plot show if there's actually outliers. So we're going to practice this with another example, but for this, I'm going to show you how we can use our calculator or the computer to figure out our 5-number summary, which kind of makes things faster. I'll do computer first since I think that's what most of you are using. So I just had you Google search Boxplot Calculator. So if I go into Google and search the words Boxplot Calculator. I'm going to pick this first one, which is this Alcula online calculator. So that's the best one I found. Again, we want to make sure we pick sample, although I don't think it's going to make a difference for the 5-number summary, but it will make a difference when it comes to the standard deviation. So I'm going to go back here and I'm just going to select all of those numbers that were in my data set. So I just put them in that box with a comma in between. I'm going to say submit data, and then it gives us, kind of not in the right order, but it gives us our 5 numbers. It gives us the median, it gives us the minimum, the maximum, the first quartile, and the third quartile. It even goes ahead and finds us an interquartile range and tells us that one of the values is an outlier. So it gives us a lot of information just from putting into that thing. So if I go back to my problem, so the 5-number summary, the minimum was 15, Q1 was 66, the median is 77.5, Q3 is 89, and maximum is 100. So are there any outliers? The computer program told us yes, there was an outlier, but let's actually calculate that. So remember, the first step is to find our IQR. So Q3 was 89 minus Q1 is 66. So 89 minus 66 is 23. So that's our interquartile range. For the lower end of the data, we're going to do the bottom of the box. So Q1 minus 1.5 times the IQR. So 66 minus 1.5 times the IQR of 23 gives us 31.5. So any values in our list of data that are below 31.5 would be considered an outlier. So since 15 is below that, 15 is an outlier. 60 is not below that, so 60 is not an outlier. So only 15 is an outlier. For the upper end, we would start at Q3 and add 1.5 IQRs. So 89 plus 1.5 times 23 gives me 123.5. So on the upper end, the value would have to be above 123.5 to be considered an outlier. Our highest number is 100. 100 is not above that upper boundary. So 100, there are no outliers on the upper end. 100 is not an outlier. So 15 is an outlier, but not 100. So now that we know that we have outliers, the way that we draw that on our box plot is we go ahead and do our box the same. We go ahead and draw our median the same. So the box starts at Q1 and ends at Q3. The median is just a line in the center of the box. Then we draw our tails sort of normal. So the upper tail, since there were no upper outliers, I'm just going to have my upper tail end at the highest number, which was 100, the maximum. Now my lower tail is where there was an outlier. So what I do is I have my lower tail end at the first number in my list that's not an outlier. So 60 was the first number in the list that was not an outlier. So I have my tail end at 60. And then what I do is I just draw either a dot or a star or an asterisk wherever there's an outlier. So I drew a little star at 15 because that 15 was an outlier. So that's how we make a change on a box plot if there are outliers. All right. So again, on your calculator or on the computer program, I showed you how you can do get the 5-number summary quickly. Let me just show you real quick on the calculator. So if I wanted to use the calculator, a TI calculator, to find the 5-number summary or standard deviation or the mean or any of that, what I would do is go to stat and then enter. I would enter my data numbers into L1. So I'm going to do that real fast with these geometry quiz scores. So then once I've entered those numbers into L1, I'm now going to hit the stat button again. I'm going to push my right arrow to go to the calc menu, and then I'm going to pick that first option, 1var stats. Now, if you have an older one in TI-83 like mine, it just looks like this, and it will automatically use L1 by default. If you have a newer calculator, a TI 84 Plus or newer, it kind of brings up a little menu where it asks you what list you want to use and then what frequency list you want to use. You're just going to leave those alone. List should say L1 by default. If it doesn't, you can push second and then 1 to make it say L1. And then frequency list, we're going to leave blank, and then you hit calculate. Right? And then it'll give you a bunch of stuff. So at the very top, it gives us that X bar. That's the mean. Down here, it gives us SX. S is the standard deviation of the sample. It also gives us standard deviation of a population, but we are not going to ever use that. So SX is the standard deviation of a sample. If I scroll down, my down arrow, I'm told the 5-number summary. So the minimum, Q1, median, Q3, and maximum are given to us. Now the calculator doesn't tell us whether there are outliers. So that would be something we'd have to calculate by hand if we're using the calculator. But that is how we can use a TI calculator to determine the 5-number summary as well as the mean and standard deviation. So it's all kind of in one thing. All right, so that is it for today's lesson. Next class, we'll kind of talk about this lesson and then we'll do some assignments on it. So thanks, guys. Have a good day.